Okay, good evening. So I have to re-record the review session because the recording cut out about 5 to 10 minutes in during the live review session. So I wrote down what the questions were, and I'm going to go back through those questions. Um, so the first question was on the learning objectives, and student wanted to elaborate on this. One of the learning objectives, qualitatively describe how the collection model outputs. Um, for example, the vehicle requirements, labor requirements, and fuel use will change under different scenarios. And so to clarify what we meant by that, so each of you has developed a collection model, an in-depth collection model in homework 4, and we're not going to ask you to do that sort of thing again, but basically we want you to understand how, be able to qualitatively describe how if one of the input values in that model changes, how would that affect your model outputs? Okay, so basically, if one of the model inputs changes, you need to be able to describe how that would change the output. So, if we change the vehicle fuel efficiency, what would that do to emissions and cost? If you switched from an automated or from a manual collection vehicle to an automated vehicle, what would that change in the system? So things like, your labor requirements, your labor cost, as well as, your time at each house and things like that. So just being able to think qualitatively about how those inputs change would affect the outputs. The next question was on the actual practice midterm, and it was on question 4. This question is, most refuse collection vehicles use diesel fuel for their engines. However, many trucks have recently switched to using compressed renewable natural gas produced from landfill gas. So using life cycle assessment, explain how you determine whether this makes sense from an environmental perspective. It doesn't say that, but that's what we're thinking. Your answer can be in the form of the diagram, which is what we expected. So basically, you want to draw the two different systems. So we have our diesel vehicle. There's some sort of garage. So the first part is, if you have, for the collection system, the vast majority of the emissions are just going to come from are going to be fuel related. You are going to have a garage. It's going to have some sort of electricity emissions. But then you have this diesel vehicle. It's going to have some emissions from combusting the diesel. The diesel itself is produced by extracting, refining, and transporting crude oil. I can't get it on the screen. Crude oil. And then, so the other part to that, so let's go to our other system real quick. And basically, so our other system, we have the same garage. We also have a truck. We're going to have some airborne emissions. Those emissions are going to be different because you're burning compressed natural gas. So, you're going to have less SOx emissions, less CO2 emissions, perhaps more methane emissions. And the CNG is going to come from the landfill. So, and this is important to think about your system boundaries. The landfill gas is going to be produced whether or not you make renewable CNG from it or not. So the landfill gas isn't part of this system. It's only the things that change. So really, your gas collection system really wouldn't change, and the only part that's going to change is the conversion of landfill gas to renewable CNG is going to take, you need to knock out the CO2, maybe knock out some moisture, things like that, and clean it up. So you're going to start with it's just going to really be some cleanup process. And then the other thing is you need to think about, though, is what was happening to the landfill gas in the other system. So now we have this additional function that this system is now treating our landfill gas. And so we need to look at, in our diesel system, what would be happening to that landfill gas if we weren't turning it into renewable natural gas. And then the two major options are, as usual, so we could be flaring the gas, and more likely you'd be comparing it against another way to produce energy from it. So if you're looking at producing renewable natural gas, you're probably already considering electricity production with the gas. So, one of these two things are going to be an offset, essentially. So for this diesel system, you're going to have the diesel's being production, and the landfill flare or the electricity is going to be, your landfill gas is going to be treated with a flare or electricity. And then the electricity would then have its own offsets associated with that. But the basic idea being, in this diesel system, that landfill gas still needs to be included, and so you need to include the that benefit as well. And those would then be, so the emissions associated with flaring the gas would then be added to this system in this offset way, because in this system, basically your two functions are collect waste and manage landfill gas. You could do a subtractive function and then subtract these from the other one as well, from the renewable CNG one as well. The next question was on the learning objectives and just trying to clarify this section, name and describe the stages of anaerobic biodegradation, be able to draw the diagram. This is specifically referring to the stages of waste decomposition in landfills. So it would be the aerobic phase, the acid phase, the accelerated methane phase, the decelerated methane phase, and the as well as the the final stability phase. So that's really what we're looking for there. The other ones would be, the stages of the stages isn't necessarily a good word, but I mean you should be able to do both, but it is a little unclear. The stages of anaerobic biodegradation, from hydrolysis to fermentation to acidogenesis to methanogenesis, and being able to understand how those all interrelate, and being able to describe how those different stages of anaerobic biodegradation work as well. So that was a little ambiguous, but there were figures in the presentations on both of those, and the midterm, it will not be ambiguous which one we're talking about. We will be very explicit about what we're talking about. The next question was on being able to draw an ET cover versus a traditional cover. So this is related to the question on the practice midterm. So this is essentially what it would look like as this is a traditional cover. And then this is essentially what an ET cover would look like. So the traditional cover, your idea is you have this clay and you have this geomembrane and a drainage layer on top of that, and your whole plan is to just seal water from infiltrating your waste. And your waste is down here. And on the ET cover, basically you have this silty, the whole idea is to get the soil to store the moisture until it can evaporate, essentially. So these evapotranspiration cover, you have this silty layer that'll hold the moisture, and so you use these in arid environments. So you can hold the moisture in this first silty layer as long as, so sand, when it's saturated, lets water flow easily into the second silt layer, and when sand isn't saturated, then it will, moisture actually will flow pretty slowly, so it can still be evaporated. So basically the whole ET cover is you have this large amount of, different types of soil essentially, in order for the moisture to evaporate before getting to the waste. And these final soil layers, these are just layers on top of the waste that you can compact on easily. So they're basically give you a foundation that you can use to build up your other layers. The next question was about was on the learning objectives. You know, basically trying to describe and you can also show on a diagram how pH, COD, BOD, and methane production vary through time in the stages of anaerobic biodegradation or waste decomposition in the landfill. And basically the idea is, so for a while, your acids are going to start to accumulate as you have hydrolysis and hold on. Basically, the methanogens are going to be inhibited whenever the pH is very low, and the pH is going to be very low during, you know, the hydrolysis is where the soluble monomers are broken up. And let me just open up that one, and we can actually go to the slide. So it's all related to this, and the idea is the hydrolytics happens quickly, the fermentation happens quickly, and that's going to lead to a buildup of these acids. So butyric acid, propionic acid, carboxylic acid, and that's going to lower the pH. And while the pH is low, methanogenesis is going to be inhibited, and it's slowly going to start up. So as hydrolysis goes on, that's going to raise your BOD and COD as you break down these biological polymers into, you know, soluble substrates to further reduce. And basically, so that's what's happening here in your different phases. This is where you basically have acids accumulating, and then as you can see, the methane production doesn't really start until that pH bottoms out, and then your pH, as the methanogens start to consume the acids, your methane generation rate goes up and the acids are being consumed, so your pH goes back up to near neutral. And then also during this consumption, your COD and BOD is being consumed, and then those start to go down, so they hit their peak right when the pH COD hits its peak, right when the pH hits its low point. Basically, the acids accumulate, which reduces your pH. Methanogenesis really starts going, so then it's consuming the acids, which gets you up to a neutral pH and gets you up to the maximum methane yield, and then also starts eating away at your BOD and COD. The next question was on MRFs. So the idea being, the question was, hold on. Oops. So describe and explain the primary economic drivers of MRFs and their relation to solid waste systems. So the idea here is to be able to explain, from a MRFs perspective and from a systems perspective, what are the primary economic drivers of the MRF? So at the MRFs perspective, they collect tipping fees when they get the waste, and then they get paid for the recyclables that come out, that they separate out and pay them. So that's how they get paid. The other part is, so a MRF doesn't exist in a vacuum. It exists as part of a solid waste system. So if you're installing something like a single stream MRF, well, that means separate collection of recyclables which is going to significantly increase your collection costs. And those collection cost increases are also a significant part of the economics of, adding a MRF. You're also going to have residuals from the MRF that are going to need to be landfilled or perhaps combusted and waste to energy. So it's really trying to understand that, the MRF is part of this system, and it can be, you can't just think of the revenue produced from the MRF. If somebody said, oh, the city made, $3 million on recyclables revenue, that may be, literally what the revenue from selling recyclables, but it doesn't tell your whole story about, the costs associated with recycling, because, you're missing out on essentially that, the cost of that increased collection and things. And, from the city standpoint, they're also going to have to pay the MRF to take the waste. So being able to think about all those things and, describe them. Another question was on draw, review, and critique potential MRF flow diagrams. So it's basically, the idea was, what are the big red flags in a process flow diagram in a MRF that you might notice? So we talked about things like, you don't bale glass. We talked about you need to recover aluminum after the magnet because, if you have ferrous still in the stream, whenever it goes through the eddy current separator, that can mess things up because, the ferrous metal is also conductive and so can also be attracted by the eddy current separator or repelled by it. And then the other major one was that, the fiber stream should be separated before you start separating. The fiber stream should be separated from the container stream before you start separating out your containers. The idea being, if you have like big pieces of cardboard or newspaper mixed in with all your containers, it's just going to make it a lot harder to separate out your containers. So the idea being, you'll have some sort of disc screen or star screen that's going to, separate out the paper and fiber, or what MRF operators sometimes call the 2D materials from the 3D materials. So those are major red flags, but there's infinite number of ways that you could make a process flow diagram wrong. But think about things that just wouldn't make sense or would make collection more difficult. Another student asked about, we talked about on the midterm question, on the practice midterm, there's question 5 that says include the approximate thickness and the hydraulic conductivity. So all that means, and in the midterm it'll be clarified, only the required K values are included. So if you look at this, and so the only layers that really have K requirements are going to be your clay, and it has to be less than 10 to the negative 7th, and then your drainage layer that has to be greater than 10 to the negative 2nd. And so this is the cover, but it'll be the exact same on the liner as well for your drainage layer and your cover. Your geomembrane is going to be significantly lower than the clay, and then the other ones don't have requirements associated with them. So that's all you'd really need to know associated with that. Another student asked about if you're using a performance-based post-closure monitoring, what are the 4 things that you need to monitor? And they were gas collection, leachate collection, groundwater, and cover. So basically, if you're trying to decide, or if you're trying to use a performance-based post-closure monitoring system, these are the 4 key attributes in your landfill that you need to monitor. So, what's the amount and quality of the gas you're producing? What's the amount and quality of leachate in your collection system? What's the risk to groundwater? Let's say if you quit collecting your leachate, and how is your cover being maintained. So, those are the four major things you need to take a look at to see if your landfill is still a risk to the environment, and you need to, maintain over time to the level until you can ensure that they're no longer a threat to the environment. And those were all of the major questions asked during the review session. From the notes that I kept, and let me look through real quick to see if there's any other ones. No, and so those were all of the questions asked for the review session. So this has been our makeup review session video. If you have any questions on anything, please email me or the forum and let us know, and we'll try to answer those as quickly as possible. Enjoy the holiday, and we will see you for the exam on Monday. Thanks.